There are some general rules to help us determine the running time of an algorithm. First rule is the loops. The running time for a loop is the running time of the statements inside the loop, including the tests, multiplied by the number of iterations. We have taken an example before about a constant Cn that printing a hello message inside a loop from 1 to n. And we said that it is time complexity C times n, and it's O of n. Don't worry, guys. These general rules of asymptotic analysis or the time complexity is just a review for what we have taken and preparing for the exercises. So next videos, we will start solving exercises about complexity and determine how these rules will affect our problem solving. Okay? The second rule is the nested loops. Analyze from the inside out. Total running time is the product of the sizes of all loops. We consider it two nested loops, and we said that we need to print a hello message. So from one to five included. So the outer loop will run 5 times, and the inner loop will run 5 times. Every time the outer loop will run, it will run 5 times the inner loop. So 5 times 5 times c is cn squared. And we said that we took the highest power, which is cn squared term, and we remove the c, which is the constant, and we have the on squared notation. The third one is the consecutive statements. Add the time complexities to each statement. So if you have a hello message, a declaration, like instantiation, addition, multiplication of a constant without interfering of the data input, so you have a constant statement. Okay. The fourth one is the if-else statement. So the worst case scenario or running time is this test plus either the else part, whichever is the larger. This is a very important note that it is not included in the previous videos. If you have if-else statement, we see the complexity of if and the complexity of else. Which is the worst case, we took it. If else is the worst case, we took the else complexity. If the if part is more complex or worst case, so we took it. So we search for the worst case for the else and if statements. The logarithmic complexity. An algorithm O of log n takes a constant time to cut the problem size by a fraction, usually by half. As an example, we have seen that we are running a for loop from 1 to n, but we multiplied I by 2. Or we have similarly running a for loop from n to I, and such that I is decreased every time by I over 2. Okay? Another example, like binary search, finding a word in dictionary of n pages, look at the center point in the dictionary. Is the words towards left or right of the center? And repeat the process with the left or right part of the dictionary until the word is found. And we have seen this complexity, these general rules of asymptotic analysis with the card, with playing cards, and we have took any big examples about them in coding. So we are now be preparing for the exercises that we are going to master the complexity with them by solving these complexity. This does not mean about only time. It's also about the space. So there is a space complexity of an algorithm or a computer program, that it is the amount of memory space required to solve an instance of the computational problem as a function of characteristics of the input. It is the memory required by an algorithm until it executes completely. Auxiliary space. Sometimes auxiliary space is confused with space complexity, but auxiliary space is the extra space or the temporary space used by the algorithm during its execution. So the space complexity in total is equal to the auxiliary space plus the input space. What does this mean? Calculating the space complexity. For calculating the space complexity, we need to know the value of memory used by different type of data types and variables, which generally varies for different operating system, but the method for calculating the space complexity remains the same. For example, if we look about the Booleans, Boolean takes in the memory 1 byte. So 1 byte is equal to 8 bits. Also a car or any of these variables. In Java, we see the Boolean and the character. C and Python, these data structures are primitives. Okay? Also in databases like SQL, PHP, the other things are being presented. If we took the short and unsigned short or int16 in other languages, we have 2 bytes. And the float, int, and long, it took 4 bytes. And sometimes the long, which is the long double or double in Java, Python, and C, took about 8 bytes. So, what we need to know here is calculating the space complexity by taking a few examples. Let's see this method. Public int sum. It took in parameter int a and int b and return a plus b. So int a here is a variable. And we said that the int has 4 bytes. It took about 4 bytes in the memory. So the variables a and b are integer types. So hence, they will take up to 4 bytes each. We have also a return statement, which is, in fact, it is making a new variable for calculating a plus b. So consider a variable called sum, or consider a variable called k. K equal a plus b. So we have created a variable k, or a new variable for making the addition, and we're returning this result. This will make a new variable of type int. And this means that we have 4 bytes for the return value. Okay? So the total memory requirement will be 2 for integer, the above parameters, plus 4 for the returning value. Hence, this algorithm always takes 12 bytes of memory to complete, which is constant. So it can be expressed in big O as O of 1. So this algorithm, in terms of space complexity, its complexity is O of 1 because it is constant. Now, let's move to exercise number 2 in the complexity and find the space complexity of this function.